Welcome to the course Data Warehousing and Data Mining. Today's topic is Data Warehouse and its core components. Myself Priyanka Gupta, I am an assistant professor at Institute of Aeronautical Engineering in Department of Computer Science and Engineering Data Science. I'll cover the topics are Data Warehouse and its core components. In this I'll cover operational database and data warehouse difference, data sources, ETL process, OLAP server, data front-end tools. So these are the core components of data warehouse. I'll also cover what is OLAP, what is the use of OLAP, basic analytical operations of OLAP. In that I'll cover roll-up. So let's get started. Data warehouse and its core components. So as we know, a data warehouse is a database that stores current and the historical data, right? So in the data warehouse, that stores the current and historical data so that it can be analyzed for market research, analytical reports, and decision making for the various business companies, right? So the key difference from the traditional operation database from this data warehouse that can be, so what is traditional database? Traditional operational database, that is nothing but while we are storing the data into the form of tables like on the Oracle and as well as on the other platforms. So that are the traditional databases, right? So here we will see the key difference between the both of them. So in the data warehouse, that are typically designed to give a historical view, right? That is designed for to give the historical view rather than to provide up to the up minute of the data, right? So the key difference from the traditional operational database is that data warehouse are typically designed to give a historical view, right? And rather than to provide up to the minute data. So the operational databases, they are providing the data, right? So in the data warehouses, we can see the historical view, a logical view of the data. The data warehouse, so that we can say they are very perfect, that perfectly suit for the long-term comprehensive analytics, right? So for example, what is long-term comprehensive analytics? The companies can use the information that are stored in the data, right? That in the data warehouses to monitor they can modify their marketing campaigns or marketing decisions so that they can improve their customer relationships, so that they can take a better decision and then they can have a better relationships with their customers. So they are perfectly suitable for the long-term comprehensive analytics, so that there will be the long-term association with the customers from the marketing companies. Data sources. What are data sources? For example, there are CRM, HRM. CRM is nothing but the customer relationship management. HRM is nothing but the human resource management. SCM, that is nothing but the supply chain management, as well as ERP. ERP is nothing but enterprise resources planning. So all of these terms is used in the business market, right? So they include the operational database, right? So that they can record the company daily transactions. So data sources are nothing but they are the operational database to store the company's daily transactions, daily records, right? So they are the only databases, operational databases, right? So operational database are those database where the data changes frequently. Here on the operational database, data is changing very frequently. So that they can mainly design for the high volume of the data transactions. We will see in the example. They are the operational databases are the source database for the data warehouse. So data warehouse is nothing but the data is stored in the operational database. So that type of data we are taking as a sources, and in the data warehouse the companies are storing that type of data. So it is also used for the maintaining the online transactions and record the integrity in multiple access environment. So these were the operational database functions. We can also say operational database has the normalized schema. So in the last class we have gone through with the schema. What are the different schema are there? So that is nothing. Operational database is nothing but the normalized schema. It is very slow for the analytics query purposes. When we are when the companies are at the end, their analysts are doing the writing the query for the processing. So if they work on the operational database, that will be very slow for them. So that is nothing but the very slow database. This database also focuses on the current transaction data, right? It is also used for the online transaction processing. So that is nothing but the OLTP processing, right? So that they can be processed later on the OLTP servers. So that was all about the operational database. On the other hand, we will see data warehouse is a repository for structured and filtered data. So in the data warehouse, after the ETL process, we are storing the data as structured and in the form of filtered data, right? So that has already been processed for the specific purpose, so that this type of data will be used for the specific purpose only. In that, the data ware collect the data from the multiple sources. So what are the multiple sources that I have said? Those can be flat files, those can be operational database, operational sources, mini sources, single databases. So that can be the source for the data ware. So in data ware, the data warehouse is collecting the data, and then that is transforming the data using the ETL process, right? ETL process. And then after that, that can be loaded into the data warehouse for the business purpose. So that was all about data ware. So that what the data ware is doing, that is collecting the data and then transforming the data using the ETL process, and then after that is storing on the data warehouse for the business purposes. Data warehouse that is having the denormalized schema, right? So here we can see the difference also in the operational database and in the data warehouse. So the operational database were having the normalized schema, but at the other hand, the data warehouse is having the denormalized schema. It is very fast for the analysis query. So the analyst and the end user can analyze their queries on other hand. We can also say the data warehouse, it is very focused on the historical type of data, because the data warehouse the data has been stored by the different data wares, that is the saved data, that is the stored data. So the stored data is nothing but the historical data. So that is very focuses on the historical data only. As well as on the other hand, the operational database was nothing but the real-time processing of the data. That works on the real-time processing of the data. Online, we can say the transactions, online transactions of the data. The data warehouse is used for the OLAP processing. So OLAP processing is nothing but the online analytical processing, right? So after that, it can be processed to the OLAP servers at the end. There were the term ETL. So what was the ETL? ETL is nothing but the extract, transform and load. So that is a process in that extract the data from the different source system, and then it transform the data. Like we can say that if that in that we have there is the process applying calculation, there is a process concatenation. So in that they are transforming the data, and then finally it is loading the data into the data warehouse system. So ETL is a process to transform and store the data on the data warehouse. ETL is a recurring activity. Recurring means the daily, weekly and monthly of a data warehouse system. So that is an activity of a data warehouse system and needs to be very, very agile, automated and well documented. So what is the mean by agile, automated and well documented? So the data, what is stored by the data ware, that will be very, very smooth in the nature, that will be very, very structured in the nature, that can be automated, that can be automatically processed, and that will be very, very well structured. So that is nothing but in that ETL, after the ETL process, the data will be stored like the agile, automated and well documented. The ETL process requires the active inputs, right? So from where? From the various stakeholders. ETL process requires the active inputs from the various stakeholders, including who are the stakeholders? They are developers, they are analysts, they can be testers, they can be top management, they can be top executives, and those who are having the technical knowledge. So the ETL process is also require the active inputs. What are the real-time inputs from the other end users? We can say the team members. So that is a online process. On that is a recurring activity. On that, the system, the ETL process require the active inputs from the different stakeholders while it is processing the queries. Data warehouse application server. So it is the bottom tier of the architecture, represented by the relational database system. So in the conventional database system, there is a architecture of that. In that, on the bottom tier, the data warehouse application server will be there. So in that, the data warehouse application server is required to build a data warehouse that organize first need to copy and raw data from the each of their data sources. So the different type of organizations, a business industry, they need the data warehouse application server to build a data warehouse, so that they can copy the data, they can transform the data, they can clean the data, they can optimize the data onto the data warehouse. This process is called as nothing as ETL process, extract, transform and load process. It is the essential part of the data migration strategy. So that was all about data warehouse application server. OLAP server. OLAP, online analytical processing server. So what it means? It is the server in the middle tier and one of the most important component of the architecture of data warehouse. So in the earlier class, we have seen the whole of the architecture of the data warehouse. But in this today's topic, we are taking the relational database systems architecture. So in that, the middle tier of the architecture is OLAP server. In that, it is the most of the important component of the that system. OLAP stands for that I have said, online analytical processing, and that allows for the rapid calculation, that allows for the uh, fast calculation of the key business metrics and planning and forecasting of the functions. And on the other hand, what if analysis of the large volume data, large data volumes. So the OLAP server is used to calculate the fast calculation of the key business metrics, planning and forecasting functions, and what are the what if analysis of the large data processes, data volumes. Data front end tools. They are nothing but they are in the top tier of the data warehouse architecture. So they are comprised of query, right? They are used for query, reporting, analysis, and data mining tools. So here we can see in this figure that there are data sources that are nothing but the operational databases and the other sources. After that, the ETL process will be occurred. So they are nothing but they are extracting the data, they are transforming the data, and after that they are uploading loading the data, right? So while they were storing the data, there will be they will store on the data warehouse, right? So in the data warehouse there can be data marts also. They are nothing but the one single type of business database, right? There metadata is also metadata is nothing but the directory of that data warehouse. They will direct the data into the different of the directories. So after the ETL process, the data will be loaded on the data warehouse, and then after that the OLAP server, it will go to the OLAP server to serve the data so that the end of the user can use that data. So while the system is going to represent the data, there will be the front end tools. On the user, with the use of front end tools, the stakeholder will be able to give the output to the end users, right? So they will be able to hand over the output to the result to the end users. So what are the front end tools will be there? We will see. So on that, the data will be analyzed. That will be used for querying or reporting. That will be used for data mining also. So these were the front end tools examples. OLAP, online analytical processing. What is this? What is this processing? In the data warehouse architecture, OLAP plays an important role for the data analysis, right? So we have seen the definition of OLAP. So we will go to its functions. So the OLAP transform the historical data into the derived and projected data, right? So it transforms the historical data into the useful data that will be derived and processed, and then it will be enable the users to easy and selective view of the data from the different perspective. So that was the function of OLAP. OLAP solutions enhance a data warehouse with aggregate data and business calculations. So at the end, when it is going to represent, when it is going to give the result to the end user, that will be enhance a data warehouse with aggregate data with the business calculations. OLAP is the technology behind the business intelligence of applications. So that is nothing but the processing, but the technology behind the business intelligence applications. So all of the business industry is using the OLAP. That is nothing but that will be applied to the many applications for the different industries. OLAP is a powerful technology for the data discovery that includes the capability for limitless report viewing, complex and analytics, calculations and predictive what if scenario. If there will be, then it will also plan the budget and forecast for that. So the OLAP is a powerful technology for the data discovery that includes the capability for limitless report viewing. So how much that can be large report viewing? So that is a limitless report viewing, complex analytical calculations, and then it will be able to predict the budget and forecast when there is a what if scenario occurs. OLAP is we've already seen the OLAP is nothing but the online analytical processing. So it is the technology behind the business intelligence applications. So what are the business applications are there? For example, the business performance management, planning, budgeting, forecasting, financial reporting, that can be analysis, that can be simulation model of the industry, that can be the knowledge discovery, that can be the data warehouse reporting. So on these type of applications, the OLAP is going to work on that. The OLAP also performs the multi-dimensional analysis of business data. So what is this multi-dimensional analysis? We will see. So the OLAP also provides the capability for complex calculations, trend analysis, and sophisticated data modeling. So as we have seen in the earlier example, that OLAP is stand for the predictive analysis. So that is nothing but the trend analysis. That is also used for the complex calculations as well. This can be used for the data modeling. But what is their multi-dimensional analysis, right, for the business data? OLAP is OLAP enables the end users to perform ad hoc analysis. So the data in that can be multiple dimension. So if the data is having the multiple dimensions, then the OLAP is enabling the end users that they can analyze the result also. Thereby they are providing the insights, they are providing the visualization and understanding. After that they can need for the better decision making. So that is also the pro of the OLAP technology, that enables the user to perform the analysis for the data that is having the multi-dimensional view. So thereby the OLAP is also providing the insight, and as well as after that he can the end user he can take the better decision for their industry. Unlike, we can say, a relational database basis, the OLAP tools don't store individual transaction records. So like we were having the relational databases that are nothing but the conventional database systems. On that, there will be the there we are storing the data as a two-dimensional records. So unlike here, the OLAP tools does not store the transactional transactional record into the 2D database, the row by column format. This is also the example of the relational database. That can be a worksheet, but the OLAP is having that is using the multi-dimensional database structure. So that is nothing but that is known as a data cubes. So that is using to store the arrays of consolidated information. So the data cube is nothing but it is the array of consolidated information that is having the 3D architecture, that is having the 3D axis to store the multiple databases. So the OLAP databases is divided into the one or more cubes. So there can be possibility the database, it can be divided into the one or more cubes, one or more data cubes. So the cube are designed in such a way that they can create and view the reports become easy. So in this figure we can see a simple data cube which is having the X, Y, Z axis, the product category, territory, and quarters. So in quarters, they are having the multiple columns Q1, Q2, Q3, Q4, multiple dimension, and in product category, that is having the PC, book, SU. In the territory, it is the data having US, GB, and Australia. So here, on the basis of that, the end user can calculate the required calculations. So that was the cube. On that, in the 3D, in the type of array, we can store the useful information, so that we can apply the query for that while we are doing the final calculations. The OLAP architecture in database is based on a multidimensional data structure, right? So the data has a form of OLAP cubes, right? So we have seen the OLAP cubes, which is having a star, a snowflake shape schema. So here we can see, if we will see in the data cube, so it is having this one cube. This is, what is this? This is nothing but it represents the multiple schemas. It represents the multiple schemas, which is having the star look like schema, which can be snowflake look like schema, etc. So in the middle of a star or snowflake, that is a table, right? So that is nothing but when we will see the high dimensional view of this schema, that will be a table that is including the data aggregation and reconcilies the various dimension. So the snowflake, a star, is nothing but it is a table that is having the data aggregation and reconciles the various dimensions, right? So when we are having the wide view of that, we can see it is in the form of table. So to query the data that is required, the OLAP usually use the MDX language. So what is MDX language? MDX queries work with OLAP members, dimensions, and hierarchy. So that is nothing but the language on that the OLAP is querying the all of the processes, right? So the MDX queries work with the OLAP members as well as with the dimensions and hierarchy. Use of OLAP in data warehouse. So the OLAP that breaks down data into the dimensions. So as in the form of data cubes. So the data cube in the will be in the form of 2D or 3D. So here we can see the example of 3D. So for example, if you are having the total sales, so it can be broken into the such of the dimensions. In the first dimension is geography dimension, and another is time dimension. So it is a multi-dimensional approach. So the geography dimensions might contain the level of country, state, and county, while the time dimension can have the year, month, and day. So that can be broke down. The OLAP can broke down into these many type of dimensions. So the OLAP in the data warehouse enables companies to organize the data information into the multiple dimensions, which make it easy for businesses to understand and use the particular data. So that was the use of OLAP, that it is storing the data into the form of dimensions. So with the use of multiple dimensions, the companies can be able to understand the data very, very easily and very, very quickly. Since the OLAP contains multi-dimension data that usually obtained from the different and unrelated sources, right? So it requires a special method of storing that data. So using a spreadsheet with rows and column is a good for 2D dimension data, but we are not using the 2D data here, but for the multi-dimension data, but not for the multi-dimension data. So we can easily store the these type of multi-dimension data into the form of 2D, but we cannot store the multi-dimension data. Instead, we can have the OLAP cubes should be used for that purpose. So what are the OLAP cubes? That is nothing but the multi-dimensional view of the data. So they are structured in a way that allow for the storing various type of data types from heterogeneous sources, and then they are analyzing it in the logical and orderly manner. So the OLAP cube consists of a numeric facts. While we have seen the OLAP cube, it looks like this, like it is having the structure like this. So in that, the data cube consists the numeric facts that is called as a measures. So here the measure can be here. This is the measure. So the numeric facts that is storing there, the facts is nothing but the table. So that is called as a if there will be numeric facts that we can call as a measure, which are categorized by the dimension. So that is having the multiple dimensions. So obviously it is having the dimensions. So the OLAP cube is also called as a hypercube. So some of the people they call as a OLAP cube to hypercube. This type of cube can store and analyze multi-dimensional data into the logical and mannerly purpose. The data warehouse would extract the information from the multiple data sources and formats, like we can say text files. It can be Excel sheets. It can be multimedia files. So the data warehouse would extract the information from these multiple formats of data. That can be the text file, Excel files, or multimedia files. Basic analytical operations on OLAP. The extracted data is cleaned and transformed on the OLAP. The data will be loaded onto the OLAP server after the ETL process. That was nothing but the extract, transformation, and then loading of the data. So after that will be loaded on the OLAP server, or we can say in the form of OLAP cubes. So where the information will be pre-calculated in advance for the further analysis. So 4 types of analytical OLAP operations are there. The first is roll-up. Second operation is drill down operation. Third operation is slice and dice operation. And fourth operation is nothing but the pivot and rotate operation. So we will take the first example, roll-up operation. So roll-up is known as a consolidation, or we can say aggregation. The roll-up operation can be performed in 2 ways. First way is it can reduce the dimensions, and the second can be it can climb up concept hierarchy. Concept hierarchy is a system of grouping the things based on their order or level. So that is nothing but it is reducing the dimension, and also it is using the it is grouping the systems into the one single format based on their order, based on their levels, different levels. So that is also known as a consolidation and aggregation. So in this example of the roll-up operation, we can see here we are having the one data cube, right? So here we are having the one data cube. So we can see in the above data cube we are having the PC, book, shoe, clothes. On the y-axis we are having the Q1, Q2, Q3 and Q4 on the time dimension, and on the location dimension or city dimension we are having the USA and Australia, 2 of the countries. So on the other hand, the other view of the this data cube will be the PC, book, shoe, clothes, the same time dimension, and there can be location dimension. In that there can be cities that is related to Australia. So that is nothing, Australia and USA. That is nothing but the Sydney, Perth, Los Angeles and New Jersey. So while we are here we can see the USA. We are going to roll up the USA country. So what will be the wide view of that? That will be divided into the different cities. So here that is nothing but the different USA cities that is having the different dimensions like Sydney, Perth, Los Angeles and New Jersey, and that is also having the different facts that has stored there. So if we want to take the Los Angeles fact, the table, the fact, so that will be the this. So we want to roll up this. So when we will view this fact, so that the value will be the 1560. So like that we can roll up the different dimensions. In this example, what I have said, the city New Jersey and Los Angeles and rolled up into the country USA, right? So the sales figure of New Jersey and Los Angeles are 440 and 1560, right? So as you can see here in this figure, the Los Angeles is having the 1560 and the New Jersey is having the 440 values. So they become the 2000 after the roll up. So if we want the combined sales figure of the New Jersey and Los Angeles, so that will be the nothing but the 2000 after the rolling of the New Jersey and Los Angeles dimensions, right? So in this aggregation process, data is location hierarchy moves up from the city to country. So that will start from the city and that will end to the country. So like that, roll up operation will go on. In the roll up process, at least one or more dimension need to be removed. In this example, the city dimension will be removed. What it means here, because if we will view if we are going to see the view of the data cube, so here in the previous example we have seen there were the different countries. So while we are doing the roll up, it will be removed. Like there were some of the cities, some of the 4 cities related to USA, but after the roll up process it will be removed. So after the roll up process, the city dimension will be removed. So that was all about the basic analytic approach of the OLAP processes, and in that we have taken the roll up process. So that was all for the today's lecture. We will meet in the next lecture. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.